Hey everybody, I'm gonna go ahead and post a video for the homework. I hope this helps you guys, but I'm gonna tell you that the concepts seem very difficult. And excuse me, I have a cold or something, so my voice is weird. But the math is pretty basic. So once you get the main math formula in your head, it should be easier. It should be a little easier. The first problem doesn't have a math formula. It's just asking to name which variable is explanatory and which one is response. And so looking at the college GPA and high school GPA, you would think that the high school GPA would be explanatory and response would be the the college GPA. So it's kind of first this, then that. So that's what I came up with there. The other answers are in the back of the book. You can look those up. But otherwise, I'll show you right here. You can do a quick pause. So basically, X is going to be, I guess, I don't know if I even want to say the independent variable. And then Y is going to be the dependent. I'm not even certain if that's how I would explain them either. But anyhow, explanatory versus response variable. So then in number 9.3, yeah, there's a formula right here. The estimated Y is 61.4 plus 2.4x. So what that means is your y-intercept is 61.4 centimeters. And then over here, 2.4x simply says that for every centimeter change in x, you'll get a 2.4 centimeter change in y. So for every centimeter length of thigh bone, you'll get a 2.4 centimeter increase in height. That's basically how you read that y hat equation, the estimate of y. So then, using the equation, just figure out part A, which is right here. You just basically fill in. Well, they want to know your y-intercept. I already told you that, and the slope. And then they want you to figure it out for part B, for if the bone or the thigh bone is 50 centimeters. So plug it into the equation. And there you go. Okay. 9.7, there's some UN data from 39 countries. Y is the per capita carbon dioxide emissions per capita, and X is the GDP per capita in dollars. Again, your Y hat, which is your estimate of Y equation, just plug and go. So for part A, it's asking you to plug in 0.8 into X, and then for the next part, 34.3 for X. Then you'll get your number. So then it says that if we use 34.3 in here for the US measure, let's calculate what the estimate of Y is. Here's the actual estimate. What's the difference, or what they call residual value? And same thing for Switzerland here. Plugging in 28.1, you'll come up with a number for Y. Compare it to the actual Y, and there's a difference called the residual value, and they want you to interpret that. So I did it right here. Let me just hold that for a little bit. Basically just plugging in and solving. You get the, for A, 1.54 and 13.1. So for the US, they're saying here, if the measurement is 34.3, you're going to come up with 13.1 if you round it off. The residual is y minus the estimate of y. And so they gave you the y in the problem. Your estimate you just calculated from up here. The difference is 6.57. That's called the residual. So what this means is that you estimated, using this formula up here, you estimated that it would be 13.1 metric tons, but the actual, 13.1 metric tons, but the actual measurement, the actual Y for the US was 19.7. So the estimate was under by 6.5. The residual was 6.5, and this means that the prediction of the equation, the prediction equation only predicted 13.1, but the actual measurement was 19.7. Therefore, the actual residual was much higher than the predicted residual, and the difference was 6.5 metric tons. The opposite is true for Switzerland. They gave you 28.1 and you calculated almost 11 as a predicted Y, but the actual Y was 5.7. The actual measurement in Switzerland was 5.7. So your prediction predicted more than the actual, which is more than the actual by 5.3. That's considered your residual. So the actual residual was much lower than predicted by 5.3 metric tons. Right. So see, 5.7 is much lower than 11. And so the actual was much lower than the predicted. And it was off by 5.3. Okay? That's your residual. 9.17, school GPA and number of viewing hours of television. Again, your estimate equation is this. That's your y-intercept. Here's your beta. And they're giving you the r squared of 0.237. And what the 237, the r squared, and I looked it up in the chapter here, the r squared says that, I'll show you right here, it means that using the estimate, or the residual sum of the squares, is 0.237 better or more accurate than just using the sum of squares. So it is 23.7% better prediction than the sum of squares. Or there was a 23.7% reduction in error when using the residual sum of squares. Hard to explain, but that's for A. There's B and C. This one's very difficult to explain, so I apologize. Basically, that r squared is saying, if you look at some of the work I did up here, that the estimate for y is this number here, and then the residual sum of squares is this equation, which equals 11.66. You can also calculate it this way. So if you're doing the residual sum of squares, you're going to get a 23.7% better or more accurate number than just using the plain old sum of squares. That's what we're saying in this problem. And then 9.27. Right here. You've got fertility rate is Y. The female economic activity is X. So the question we could pose, the one I proposed is that, is there a relationship between the number of females in the workforce per 100 men in the workforce and the fertility rate? This is the Y hat equation they give you. We've seen this pattern before. The R squared is 3207. So when you take the square root of that, you get negative 0.57 or 0.57. But because of the direction, it's negative. And this tells me that there's a negative correlation between female economic activity and fertility rate. The higher the fertility rate, the lower the female economic activity. In other words, the more children they have, the less likely they're going to be out in the workforce, the females. That's all of Chapter 9. Apologize, I can't give you much more detailed explanation than what I did, but having trouble